Okay, so in this video, we are going to check out some introductory stuff to help you get through worksheet 1, right? So hopefully you saw the worksheet 1 that was sent out in that first email. You could have gotten it also from D2L, whatever, right? But basically what we're going to talk about here is some prerequisite information that's going to help you get through that worksheet. Okay, so the first thing we have to talk about are different types of numbers. All right, so what are different types of numbers, right? There are things called whole numbers. You probably heard that phrase before. There are things called integers. There's lots of other types of numbers, but these are the two that we really want to be comfortable with. And then really what you want to do is be able to recognize ones that aren't integers or whole numbers. Okay, so what are we talking about? Whole numbers are whole things, no parts, no fractions, no decimals. So basically nice numbers like 0, 1, 2, 3, 4, right? And this keeps going 9, 10, blah, 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 forever, right? Up to 426 or 427 or 428 or 420 or whatever. It just keeps going forever, okay? So whole numbers are nice positive numbers. Integers are also nice numbers. Nice meaning no parts, no fractions, no decimals. But they might have negative now. So it is the same as whole numbers, right? It has that same 0, 1, 2, 3, blah, blah, blah. But it now also has negative numbers. So -1, -2, -3, -4, all the way down. So think it goes both directions. So positive and negative, right? Positive and negative, okay? But still, no crazy decimals, okay? So whole numbers and integers, no decimals, no fractions. Integers are only the positive. Integers could be positive or maybe negative. Okay, so now there are names for these other things, but it's not a big deal. But you should definitely be able to recognize non-integers or non-whole numbers. Basically, what you're talking about are all the crazy decimals in between these, right? So there's a bunch of stuff between 0 and 1, between 1 and 2, between 2 and 3, between 3 and 4, between 4 and 5, right? All the numbers between these whole numbers or integers, whatever, are things that have a whole part and a decimal, a whole and a decimal, right? That decimal point separates the whole part and the fractional part, right? Okay, so make sure you can identify those. Now, we got to talk about this idea of place value, right? So if I gave you this number 555, comma 555, right? It's a bunch of fives, I know, but it's one number. But you remember, if you read that, this would be 55,555. So where you put the 5 tells you something, right? So remember that usually when you don't see a decimal point, it's assumed to be all the way to the right. So this is 55,555 whole things, right? Because of the decimal point. But that first slot, those are your singles. The second slot, those are your tens, then your hundreds, then your thousands, then your 10,000s, right? So the fact that that's a 5 in that first slot is really saying you have 5 singles, which is just 5. 5 in that second slot means you have 5 groups of 10 or 50. 5 in the third slot means you have 5 groups of 100, which is 500. 5 in the next slot means you have 5 thousands or 5,000. And then 5 of those 10,000 or 50,000, right? And then the point is when you add these backs, you look 5, 5, 5, 5, 5. And that's what's really creating that number 55,555. So you really have 5 groups of each of the individuals, right? All right, now the stuff to the right of the decimal is a little weirder, right? So again, when you see this number 5.555, right, the decimal point is your best friend, and think anything to the left, that's the whole part, and anything to the right is part of something, right? So it's a fractional or decimal part, okay? But if you remember the names of these things, that very first slot, those are what's called the tenths. The second slot is the hundredths, and the third slot is the thousandths, right? Because what's really happening here, like that phrase tenths, what it really means is 1/10, right? So when you say tenths, or in this case, since there's a 5 there, just like it was up here, you're talking about 5 of those tenths, right? But if I take my 1/10 and then multiply by 5, that's what's putting a 5 in that very first slot to the right of the decimal. That's this 0.5. Then hundredths is 5 of those 100ths, right? So what you're really doing is you're doing a 100th, right? You're dividing by hundredths. But see, look, it's 2 slots. Then when you multiply by 5, that's what's creating 0.05. And then in thousands, you're talking about 5 of those 1,000s, right? But that 1,000s, oh, sorry, is what's created. But see, look, it's in the third slot. Now, when you multiply by 5, no, don't do that. Hold on. I hit it too many times. 1 divided by 1,000, multiplied by 5. But you see how it's putting a 5 in that third slot. 1, 2, 3, right? So that's what's creating the 0.005. But then when you put them back, see, look, 0, 5, 5, 5, right? So that first 5 is really referring to 5/10ths, then 5,000 hundredths, then your 5,000ths, right? The quickest way to remember it is just however many slots you want to go to, that's how many zeros, right? So it's the first slot, 10 has 1 0. Second slot, 2 zeros. Third slot, 3 zeros, right? So the decimal is a little weirder, but that's a quick way to remember it. All right, so watch out for that place value stuff, right? So basically what I'm talking about here is you can, on that worksheet, we'll talk more about this later, but go through these type of problems. It's talking about whole numbers, integers, whatnot. And then what we're really trying to get to is this whole idea of rounding. But before you can round, you got to be able to recognize different place values. So that's what we're building here, is this idea of recognizing place values, which we'll talk more about. But you guys remember how to round? So rounding is all about taking a not so nice number and making it nice, right? You're going to the nearest whatever, okay? So sometimes they're going to tell you what to round to. Sometimes they won't tell you what to round to. Sometimes you're going to have to figure out what it's round to. You'll see that as we go through. Okay. But basically, if you guys remember, you have to, if they do tell you what to round to, you have to identify what they wanted to round to. And then basically your number, if it's going to be in between two of these nicer ones, right? If you're more than halfway, you go up. If you're less than halfway, you would go down. Or you go to the next digit. And if it's above 5, go up. If it's less than 5, go down. Right? So imagine I gave you this number. I want to round to the nearest 100. Okay. So now, what does that mean? So think of, okay, here's a number line. Here's 0. Okay. So this is the number 125 point blah, right? So everyone's like 125 and then part of 1, right? But as far as hundreds are concerned, see, it's 100, right? Then all the way up to the next one would be 200. So where would 125 be? Somewhere between, okay? Your best friend would be right in the middle, is 150. So 125.231 is somewhere between 100 and 150. But the point is, if 150 is the halfway mark, is this number closer to 100 or is it closer to 200? It's much closer to 100. That's why you would round it down to 100, right? Or the shortcut is just identify the decimal where you want, which on the hundreds, look at the next one. Oh, that's less than 5, go down, right? What about the nearest whole number? Okay, so as far as whole is concerned, this is 125 whole and then a little bit more. So now we're going to go up to 125, then the next whole would be 126. But this would fall somewhere in here. But it's not quite to 125.5. So again, it's still closer to 125 than it is 126, right? So there's the whole slot. Oh, look, that's less than 5, so you would go down. What if I wanted to round the nearest 10th? Oh, well, the 10th slot is right there. You look at the next one, that's a 3. So again, you would go down, so it's 125.2, right? But that's the point. You can do it quicker once you get used to it. Just to identify what slot you want, look at the right one, and then go up or down. Okay. Now, sometimes when you're trying to, talk about parts of things, sometimes when they break down, depending on what they're talking about, they break it into other units, for example, feet and inches. So like consider measuring a piece of wood that's 6 feet, 4 inches. So we have 6 whole feet, and then we have 4 inches more. Or in other words, we have 6 whole feet, but then we're talking about part of a foot. Okay? Now, one thing I want to stress here, okay? If you're talking about part of something, and especially if it doesn't work out nicely, you have to watch what you're doing in terms of, with money, it works great. I mean, when you see this, everybody sees, oh, it's $6.40, right? You read that. But what's really happening here is this is 6 full dollars, and then this is 0.4 of a dollar. Okay, but remember, it turns out that 100 cents is exactly the same as $1. So saying part of a dollar is the same thing as saying 40 whole cents, right? But the point here is when you're talking about here, how many inches are in a foot? not 100. So you got to watch what you're talking about. If you remember, or you can check it out, but 1 foot turns out to be the same as 12 inches. Okay, so the point is it's not going to work out that nicely, right? Okay, so visualize this. Here's 6 whole feet. Here's 7 whole feet. Okay, what it wants me to do, it wants me to round to the nearest foot, nearest half of a foot, and nearest quarter of a foot. Okay, but notice there's no reference to inches. That's the whole point. We're trying to get rid of the inches and round to the nearest part of a foot. Okay, forget the inches for a minute. So this is 6 whole, this is 7 whole. So right in the middle, this would be 6.5, right? 6 whole and then halfway. In here, and then in here, you can break those in half. But you see you've broken into 1, 2, 3, 4 pieces. So this would be 6.25, right? Because it's half of a half. Half of 50 is 25. 25, 50, 75, 100. Right? So this would be 6.75, right? 25, 25 more, 25 more, 25 more, right? So this is 6 whole feet, 7 whole feet, half of a foot, quarter of a foot, right? This is 1 quarter, 2 quarters, 3 quarters, 4 quarters, okay? This is what they're after in terms of whether you're talking about half or quarters. But that's not how inches and feet work. So if you had 6 full feet and 0 inches, if you made it all the way to 7 feet, now you're talking about 6 feet and 12 more inches, right? 12 more inches would be a whole foot. We made it to 7, right? But halfway would be 6 feet, but half of 12 would be 6 inches. So having 6 feet and 6 inches would be the same as 6.5 feet, right? But halfway here, this would be 6 feet. Between 0 and 6, halfway would be 3 inches. So having 3 inches is really the same as a quarter or 0.25 of a foot, right? But you're breaking it up into 1, 2, 3, 4 chunks, right? So it's 3, 6, 9. So this would be 6 feet, 9 inches. Then 3 more would get you to your 12, right? So 6 feet, 6 inches is really the same as 6.5 feet. 6 feet, 3 inches is the same as 6.25 feet. 6 feet, 9 inches would be the same as 6.75 feet, right? But the point is, yeah, the numbers get crazy because there's not exactly 100. That's the way our numbering system works, right? That's why it's just annoying, but it is what it is. All right, but anyway, we want 6 feet, 4 inches. All right, so where is that? So 6 feet, 4 inches would actually end up in here, right? It's more than 3, but less than 6. All right, so first off, they want the nearest foot. All right, sorry, we're right here. My nearest foot is either going to be down at 6 or up at 7, okay? Well, that 4 inches is less than halfway. So if it's less than halfway, then you would go down 6 feet, right? What if I wanted the nearest half of a foot? Okay, well, the half of feet are here, here, and here, right? So having nothing would be at the very beginning, having a full foot would be here, or half a foot would be in here. So 4 inches, is it closer to having nothing, or is it going halfway? Well, 4 is closer to 6 than 0, so you're closer to the half a foot. So you would round this to 6.5 feet, right? Because it's closer to 6 inches than it is 0. All right, now what about the nearest quarter of a foot? Well, again, 6 feet, 4 inches is in here, which would really translate to somewhere in here. So now if we want quarters, you're now breaking it into 4 chunks, right? But again, where is this? It's in here, right? It's getting closer to that one. So what is it closer? Is it closer to 3 inches or 6? Well, 4 inches is closer to 3, so you're going to round it down to this one, which means you're really going to round it down to a quarter of a foot, right? So this would be closer to 6.25 feet, okay? But that's what they want. They're breaking it down into whole 6 feet and then a part of a foot. 4 inches is closer to a half. 4 inches is closer to a quarter as opposed to, the next quarter, right? So it's kind of the same thing when you get to that worksheet, right? See, this first problem is talking about hours and minutes. So when you do quarters and halves over here, there should be no reference to minutes. It should be whole, hours, point, blah. So it's either going to be, if you see, like, these are all 5 hours and some minutes, it's either going to be 5 hours, 5.5, or 6. Quarter of an hour is either going to be 5, 5.25, 5.5, 5.75, or 6, right? The nearest quarter of an hour. Right on. Okay. Last thing, at least that's going to help you with some of this, is kind of a real quick crash course in fractions, right? Honestly, what I would recommend when you're doing this worksheet, try these on your own first. We can talk about those later, right? But see what you can do, like hopefully how fractions you draw those, what they mean to you, okay? And then that might help to understand how these things work when we get there, okay? But if you guys remember how to multiply fractions, add or subtract fractions with denominators that are like or unlike, and then dividing. Okay, so the short version, if you guys remember multiplying fractions, right? The short version is you can multiply across, right? So you can literally just multiply the tops together, multiply the bottoms together. Use a calculator if you like, whatever. But it's basically 9 times 15, right? There's your 135 for the top. And then on the bottom, you got 5 times 6, which is your 30 for the bottom. Great. Now, I don't know how much you guys have done with that before, but I would imagine you say, oh, then you can reduce that. Okay, great, sure. But do realize there's nothing wrong with this answer. You don't have to reduce. That is the correct answer. You could reduce that, right? What do they have in common? Well, they both end in a 5 and a 0, so they're divisible by 5 for sure, right? So if I get rid of a 5, the top would turn into 27, and the bottom, 30 divided by 5, is 6. And that's where it came from, but whatever. But that would be the reduced version, right? You can get rid of a 5. Yeah. Well, wait a minute. 27 and 6, they still have a 3 in common, right? So you can get rid of a 3. 27 divided by 3 is 9, and 6 divided by 3 is 2, right? Realize you got a 5, then we did 3. 5 times 3 is 15, so you could have reduced by 15. Let's see, look. 5 divided by 15 goes straight to the 9. And if you do 30 divided by 15, go straight to the 2, right? But do realize that which one of these is the correct answer. They all are. There's nothing wrong with any of these. This is usually the most commonly done one because that is the one that's simplified the most, right? 9 and 2 don't have anything in common, right? And see, it makes you realize what we're talking about here. See, no, don't do that. 135 divided by 30, right? You see, it gives you this 4.5, right? So taking 135 divided by 30 is really 4.5, 4.5. But look, 27 divided by 6. Oh, look, 4.5. What is 9 divided by 2? 4.5. They're all saying the same thing. They're just different ways of saying it, right? Also, do realize that maybe I should write it over here. Okay. So one way to do fractions is multiply the tops, multiply the bottoms, and then reduce if you can, if you want to, right? Or you could actually cancel stuff first, right? So think 9 and 15 are on the top, 5 and 6 are on the bottom. So does anything on the top have anything in common with the bottom? Well, you can play around with it, but hopefully you'll see eventually that 5 goes into 15 3 times. And then maybe 9 and 6, they have a 3 in common, right? So 3 would go into 9 3 times, and 3 would go into 6 2 times. So now on the top, you're left with just 3 times 3, which is 9. And the bottom is just 2. Oh, look, there's your 9 halves, right? Way faster. So you can multiply, then reduce, or you can cancel some stuff first and then multiply later. Either way, you're going to get there. Okay. How do you add or subtract fractions? Well, think, coming back to this money idea. I don't know what it is about money, but you put things in money, people always get it. If I said to you $5 and then $3, well, duh, that's $8. But if I said to you $5 and then 3 cents, right, would this be the same as 8? No, that wouldn't work because they're different, right? $5 and 3 of the same things would be 8 of those things. But at $5 and 3 cents, they're different, right? It wouldn't be 8. It would be, $5 and 3 cents. Okay. So the point is that theme's going to come over and over and over again. In order to add things, they have to be like each other. So what this is saying is you're taking 4 out of 5. Oh, 3 out of 5. So we're breaking things into a common 5, which means they're the same. 4 of them plus 3 of them would just be 7 of those 5s. So the short version, if they're a common denominator, just add the tops, bring along that common denominator, right? Okay, now, if they're unlike each other, right? Think of like if you break something into fifths and you break something into sixths, they're not the same size pieces. So you can't just add them together. You need to get them to be the same. So you got to find a common denominator. The easiest way is just multiply them together. 5 times 6 is 30, right? So I need to change it so this is 30. But the problem here is you've changed the problem, right? So what you did was is you multiplied the bottom by 6, right? 6 times 5 is 30. But if you do that, you got to multiply the top by 6 to keep it fair. So now 6 times 2 is your 12. But see, look, check this out. The original number here was 2 fifths. So 2 fifths is the same as 0.4. You changed the top, you changed the bottom, right? But what is 12 divided by 30? Oh, look, it's the same number, right? It's still 0.4. So 2 fifths and 12 over 30 are the same number. They just look different so that it has this other denominator. The same way I want to take 5 6 and change it to something out of 30. Well, you multiply the bottom by 5 now, right? 6 times 5 is 30. But if I multiply the bottom by 5, you got to multiply the top by 5. 5 times 5 is 25. So check this out. The original number here was 5 6. Whoa, crazy decimal, whatever, but just keep that in mind. It's 0.83333. Well, what is this? What is 25 divided by 30? Oh, look, it's that same crazy number, right? But that's the point. 5 6 and 25 over 30 are saying the same thing. They're just looking different so that these are now, the same, so I can talk to each other, right? 12 of these plus 25 of these would be 37 of those 30s. And there you go. You could try to reduce it, but do they have anything in common? Nah. So who cares? Okay. If you really want to know, I could go through why this shortcut is for division of fractions, but honestly, it's not that big of a deal moving forward, right? Honestly, you can just use a calculator on this, but it's worth talking about it a little bit, right? But if you guys remember, the shortcut to dividing by a fraction is you change the division to multiplication, and then you take the second one and you flip it, right? The reciprocal. So the first one stays put. Dividing by a fraction is the same as multiplying by the reciprocal, right? And now you're right back to what we were just doing. Shortcut, you could just multiply tops. It's 40 over 15. And then you could reduce it, right? You reduce it by 5. 5 goes into 40 8 times, and it goes into 15 3 times. So this would work, or this would work. You could have left it. Who cares? Or again, let me rewrite this. Write that 4 fifths times 10 thirds. You could have used that trick of you could cancel some stuff first, right? Because 5 goes into 10 twice. Now, 4 times 2, 8. You're just left with 3 at the bottom. Bam, 8 thirds, right? So it's up to you. But the shortcut is just multiply by the reciprocal. All right. Last thing here. We're going to be talking about a percentage a lot in this class throughout the whole semester, right? But short and quick version of it for now, at least to get the idea. Usually when you're talking about percentages of things, you're talking about parts of things, okay? Like if I had 100%, then I have the whole thing. If you have less than 100%, then you don't have the whole thing. You only got part of it. And even if you had more than 100%, that means you have more than the whole thing, right? So think 100%, that's your whole, right? Right, and that's your, if you have less than 100%, then you have part. So let's start with that. When you see 3 fifths, you have part. You have 3 out of 5. So imagine you're having a whole, and what this is saying is you break it up into 5 pieces. Right? So you have this whole 1, 2, 3, 4, 5 pieces. But I'm keeping 3 of them. So what I'm really doing is I'm keeping 1, 2, 3 of those 5 pieces. Okay? Well, what's another way of saying that? I mean, you kind of look at it. Okay, percentage-wise, do I have the whole thing? No, clearly not. So it's not 100%. It's less than 100%. But if you look at it, you look like it's more than half the picture is shaded. So it should be more than 50%, right? That's halfway, right? But how can I get to that specifically? Well, if you pick up a calculator and you say, what is 3 divided by 5? It turns out to be 0.6, okay? It's a pretty common theme you're going to see a lot throughout this class, but don't lose the fact that when you pick up a calculator and do a division, are you still talking about a fraction? Are you still talking about a comparison? Yes, right? It's just that you're comparing it to 1 now, right? So like okay, like here we were talking about reducing. You don't have to reduce necessarily. You could get bigger if you wanted. So what I'm saying is 3 out of 5, you could go the other way. Like imagine this were like 20, right? So you can multiply by 4. 5 times 4 is 20. But if you multiply the bottom by 4, and multiply top by 4. So then this would be 12. right? So saying 3/5 is 0.6. But if I say 12 divided by 20, oh, look, it's still 0.6, right? You're just changing the top and bottom. It's the same thing here. When you do the decimal, you're changing it, but you just realize you're comparing it to 1 now. So it's 0.6 out of 1. That's what you're really doing, okay? But usually when you want to do percentages, like the whole is 100, so I really want to get to 100. So you're multiplying out of 100. So to get to 100, you'd have to move the decimal over 2 slots. Saying 60 out of 100 is also the same thing as all saying 0.6. Okay. Once you get it out of 100, then that's your percentage, right? So basically, writing it out of 100, you can drop the 100 and use this percentage symbol, right? That's what a percentage means. It means out of 100. Okay. Or the short version is whenever you see a decimal, just move it over 2 slots, and there's your percentage. Okay. All right. So hopefully that should give you a little bit of preamble or a little hopefully some confidence to check out that worksheet 1, right? So make sure that you can round things, give me different examples of numbers, more rounding, draw some pictures with fractions, what they mean, using that idea of adding, subtracting, multiplying, dividing fractions, right? So here, this is going from percentages to decimals to or fractions, just seeing how they all relate. And then a little bit of stuff of using percentages. I'm going to let you try that, and then we can talk about it later. All right. So once you got that down, check out that worksheet 1, see what you can do with it, right? Make sure you guys are posting up on the discussion panels, right? And also, if you have any if you have questions about this stuff, post it on the discussion panel. See what everybody else has to say. Or you can come see me, talk to me, and then eventually I'll send out a video that goes through all this, right? But you got to try it first. All right.